So the today's topic is what is an identities? Big question, right? What is identities? So identities is, in the previous classes we have studied the linear equation in one variable. Remember linear equation in one variables?
Yeah.
Right? We have also learned that an equation contains two algebraic expressions on either side of the equality sign, right? Remember we have learned the linear equation where we can take any linear equation. Suppose 2x plus 1 is 5, right? This is the linear equation. In this linear equation we have equality sign, right? So suppose, for example 3x plus 2, I am taking one more example, 3x plus 2 is equals to 11, right? In this equation for x is 3, suppose we are finding for x is 3, right? So what will be the value? X 3 times 3 plus 2 is 9. Means this is the left hand side. 9 plus 2 is 11. This is also 11. Means left hand side is equals to right hand side. Right? Left hand side is equals to right hand side. So what is this meaning? This meaning is this. Thus LHS is equals to RHS when x is equals to 3. In the other words, you can say that the equation 3x plus 2 is equals to 11 is true when x is equals to 3. Because when you substitute x is 3, so both the side we have the same value, right? So we can say that yes, it's true. Also, it does not hold good for any other value of x. On the other hand, the equality x plus 2x is equals to is true. Suppose I am writing x plus 2x is equals to 3x, right? X plus 2x is equals to 2x. 3x is true for all values of x, right? What is this meaning? This type of equalities are known as identities. Because if your equation is equal, if you can substitute any value of x, then you will see both the side we have the same value. This will come again in the, okay? So identity means an identity is an equality which is true for all values of the variable. But in this case what happened now? If you put, look at the board, don't write, okay? I will give you the time for writing. Try to understand first the concept, okay? Then write. So see, here if I take x is equals to 3, then your LHS is equals to RHS. If I take here 2, x is equals to 2, suppose I substitute, you will not get the same value. So the meaning is linear equation satisfied for the one value, right? The equation 3x plus 2 is equals to 11 is true when x is equals to 3. But in identities, you can use any value for x. Both the side you will get the same answer. For example, if I take x is 1, see 1 plus 2 is 3 times 1 will be 3. See 3 is equals to 3. If I substitute 2, so x is substituted by 2, so 2 plus 4 is 6 and 6 is equals to 6. This is the difference. Understood the difference? In linear equation, only one value will work. Okay, but in identities, any value will give it the identity. So an identity is an equality which is true for all values. Okay, understood the concept? Okay, now see more. Now the very important part of this is where you will use these identities, right? So we shall now study three standard identities. Okay, we will learn only three standard identities. Okay, if three you know it, other you can do it. Okay, so we will learn three types of identities here. Three types of identity. Why? These three identities are very useful in factorization and simplification of algebraic expression. Where is used these identities? Factorization. After this identity topic, I will explain the factorization. Okay. So there is a two type of spelling. Factorization, use of these identity. Okay, uses. So one is factorization and other is simplification of. Remember na, algebraic expressions we have learned it in the last grade. Algebraic expression, all type of multiplication. Remember the product, monomial by monomial, monomial by binomial, binomial by binomial, polynomials by polynomials. So there is a, so these are the uses. It's a very useful actually, because when you multiply with the normal way, okay, it will take time, and the chances of mistakes is also definitely increase. But if you use the identity, you can get your answer easily, and you can save your time also. Okay, so these are very important and useful identities. Now yes, so which are very useful in our work. These identities are obtained by a multiplying a binomial by the another binomial. So basically these identities work in binomial with the binomial. Okay. Now come to the identity number 1. Now we are discussing the identities in detail. Okay. So the identity number 1, identity 1. Identity 1 is if we have written in 2 times, a plus b, a plus b, right? Like a square. Yeah. So a plus b, if we have 2 times, can you write it in this way? A plus b square. Yes. Can we write it in this way?
Yes.
So this or this is same, right? As we are using the square. So now how you will do this? A plus b whole square. Now see, a plus b whole square. So you can write it a plus b or a plus b. Now see how you will find it, the identities. You remember Now check a plus b is which type of algebraic expression? Tell me. A plus b, which type of algebraic expression? Monomial, binomial, which type?
It's a monomial.
Really?
It's a binomial. Binomial.
Yeah, it's a binomial. And this a plus b is also binomial. So I already told you these identities are obtained by multiplying a binomial by another binomial, right? Now check how you will solve this. Same like a algebraic expression. We already done in the previous classes, right? So a, first you will take a, multiply with the whole parenthesis, which is a plus b. Now the remaining plus b, you will write it here and again use the same parenthesis. Now tell me which property I have used here. Tell me.
Distribute property.
Yes, very good, very nice. Yes. So this is by distributive. I'm not writing the full name. Here is no space. Okay. So distributive property we have used here, right? So now you know it how to solve it, right? Distributive property. This which this part multiply with this part, right? Now do it. A times a will be a square, right? A square. A times b will be ab. B times a will be ba plus b times b will be b squared, right? Now ab and ba, which is same or different? Can you tell me? AB and BA, is this same or change? Same, correct. Absolutely. Correct. Yeah, right, because it's a multiplication. Okay, AB and BA both are same because AB means A multiply by B, or BA means is also B multiply A. And as you know it, in multiplication we have order property. If you write it in this way, both are the same. There is no change. If you remember in the smaller grade order property, in the higher grade we have learned commutative property. In multiplication, if you change the order, the product remains the same, right? So you can write it in any ways. So AB is better, of course, because alphabetically A is first, right? So AB is better. So AB will be 2AB, right?
Square.
Not a square, beta. It's a plus sign.
Yeah. Plus
It's not a multiply sign. See, A times A. When you multiply A times A, look at the board this side. A times A will give it A square, right? But A plus A will give it 2A. Got it?
Yeah.
Remember the property. Remember this fundamental. So when you multiply two numbers, so it will go in the square. But if you add it, it will become 2A. The same concept here. AB plus AB will be 2AB. What is it?
Yeah.
2AB, not AB square. Understood? Because both are in addition. There is a plus sign. Plus sign is what is? You will add it, right? So A plus B identity is this. Now we got the identity format. So A plus B whole square, A plus B whole square. Now you can write it A square plus 2AB plus B square. This is the first identity, we got it. So the identity number 1, you understood, A plus B whole square is equals to A square plus 2AB plus B square, right? So clearly this is an identity, since the expression on the right hand side is obtained from the left hand side by actual multiplication, right? So one may verify that for any value of a and any value of b, the values of the two sides are equal. Okay, so if you give any value of a or any value of b, automatically you will see the same answer in both the side. Okay, both the side you will get the same answer. Okay, so this is the main, because left hand side is equals to right hand side, such as equality true for every value of the variable in it is called the identity. Okay, now come to the next, or if you want I can give it to the this way also. If you want I can give it to the one more important way. Suppose a plus b whole square, right? We have done it this one. So a plus b whole square is, as you know it, a square plus 2ab and plus b square. Okay, so a, you call it a, what you call it, a first term, right? This is
Yeah.
a is here the first term and this is the second term. So what you call
Yeah.
it is here square of the sum of sum of two terms. Why? See, look at the board. Square of the sum of the two terms, right? This is the explanation of this left hand side. In right hand side, a square is what? Square of the first term. How you can write it? Square of the first term, right? A square means you are squaring the first term, right? Square of the first term plus 2 times first term times second terms. Now this is the detail of the, why? Because 2ab means 2 times first term times second terms, right? And the third part is square of the second term. This is the explanation of the identity 1. Okay, so that whenever you will solve the questions you will never confuse. Okay, understood? Terms. Okay, now come to the second identity. I am changing here only the second identity. Second identity is any idea what is the second identity? Identity number second. Now we are going to the negative. A minus b whole square or squared. A minus b whole square, or you can say square. What is this meaning? Means a minus b times a minus b, because here is the square sign. Same. Square means you will write it in 2 times.
Same
Right?
twice.
Yeah. Now,
Like 1 minus 1.
a same we will do like the previous one. Okay. Which property we are using here? The second.
The distributive.
Correct. Distributive. Now solve it. Okay. Same. This. So a times a will be a square minus ab minus ba plus b square. Now, again AB and BA will be, AB and BA will be what?
2AB.
It's positive or negative. Now use your integer.
Positive.
Really? Negative, negative will be?
Negative.
So negative 2AB plus B square. So this is the identity of A minus B whole square. Now, can you tell me what is the difference between the last identity or in this identity? Second identity, what is the difference? Can anyone explain?
So,
Hmm.
so it's like it's the same thing, but the signs have changed.
Where we have signs, change the sign.
So
Hmm.
we have negative 2AB plus B squared. That's where it has changed. Because in the last one it had all plus.
So you can write it in this way, or if you want, you can write it in this way, okay? And sometimes you will see in some places and some worksheets there is a, see, you can change the addition variation. So you can write it in this way also, okay? Both the way are correct, okay? So you can write it A square plus B square together, and negative you can write it in the end. So both the way are absolutely correct. If you want to understand the detail of this, so how you will write it? Square of the difference of two terms, okay? Square of the difference of the two terms is equals to square of the first term plus square of the second terms minus 2 times first terms times second terms. Understood? That the proper explanation, the detailed explanation. So if you want, you can write it in like just like a identity 1. As I explain it now, you can write it in the explanation form also, just for your reference, okay? Whenever you have doubt, you can check your notes and see the detail, okay? Now the third standard identity is, we have done two in identity, okay? So basically all three identities we call it as standard identities, okay? We have many identities but standard is only 3. So we have learned two, now third. So third identity is, suppose one is, we have one is positive and one is negative. One binomial is positive, one binomial is negative. Then how you will do this type of questions? You can use it directly, okay? We will not do the same process in all the questions. We directly use it for the question. I tell you how, okay? First try to understand the concept. Now again, which property will use it here?
The distributive.
Yeah, same. So
Distributive.
yeah, A minus B plus B, again A minus B, right? Now as you know it, we are using the distributive property. So A square minus AB plus BA minus B square. Now check the middle two terms and please let me know what should we write it in the next step. Check it and tell me fast.
Oh, it should be positive.
One is positive, one is negative, already given in the questions. What does this mean?
Wait, can you say that again?
What should I write it, beta? What should I write it? How you will solve a negative AB, positive BA? What does this mean? You know.
I think it means that it's a negative.
First tell me, AB and BA is different?
No.
AB and BA is different? No. When AB is positive and one AB is negative, then what does this mean?
It means it's wait. Then it wouldn't be positive or negative. Yeah.
When we have the same number with the opposite sign, definitely it will cancel, right?
Yeah.
So what is remaining? Only B square. So what is this identity? A plus B and A minus B, always give it A square minus B square. You can directly use it in the question. This
Wait,
is
wait, wait. How is it only B square?
so because AB and plus AB and the minus AB we has cancelled now. Both are
Yeah.
same. See, one AB.
Also, that's B square. Okay, okay.
Okay, now see, look at here again. Negative AB plus BA, right? Can we write it plus BA is AB because both are same? Yeah? Can we write it? Now check. Negative AB, positive AB, we can cancel. Like a normal number, negative 5 plus 5 is what? We can
Sure.
cancel, no?
I
When
got
the
that.
same thing, when we have the same thing with the opposite sign, one is negative, one is positive, it will give it 0 only. Okay? Understood?
Yeah.
So this is the third identity.
Okay.
So these three identities are the standard identities which we will use in our questions, okay? And make it and applying. Now we will see some questions. We are applying the same identities in the questions and see the magic, okay?
Yeah.
Now see the some example based on identities, okay? So first is x plus 2 this one it will not work, wait. So x plus 2 whole square. The first question is x plus 2 whole square, right? So how you will find it? So there is a two variation. First is long method, as you have done it in the algebraic expressions. Which method you have done in the algebraic expression? X plus 2 times x plus 2, which I have explained in the identity also, right? How identities has arise. But here we are not using this one, okay? We are not using this identity. We will use directly the identity, okay? We will not go for the long method. How you will solve it?
By using distributive property.
Not distributive. We are not using the long method. Now here, this is the long method. We are not using here, okay? Now check. What is A here according to your identity? Tell me.
A is, I think.
A is x, right? And B is 2, right? Yes.
Yeah.
Now what is your identity? A plus B, because this is the plus. So A plus B whole square. A plus B whole square. What was the identity? A square plus 2AB plus B square, right? This is your identity. Now you will substitute your value in this identity. So A is x. So x square plus 2 times x times b plus x times 2, sorry, it's my bad, it's a 2 square, right? Now you will be simplify this, okay? So a square will be x square will be x square plus 2 times x times 2 will be 4x, right? Plus 2 square is 4. This is your answer. Within a second you can find the answer x plus 2 whole square. If question is this, you can easily find the answer with the help of identity. No multiplication binomial with binomial. You will never use the long method now. Okay, you can directly use the identity. See, this is the first question. That's why we are writing these formalities. Otherwise, no need to write the formalities. You can directly go for the steps. Okay, now come to the second question.
What if you like use the longer method so you can get a little comfortable
No,
with
no,
that
no, no,
first?
no. If you use the longer method, you will get the same answer. Okay, but identity is used for the multiplication easier, na? So why we go to the, because in factorization or the other difficult question, okay, the fractions, rational number will do the same. We'll use the same identity with the other number system also, right? So that time it will be difficult for the distributive property and all. So this direct method will help you. Okay, now next is, so see, according to the grade, we upgraded the, we learned the advanced thing, na? So this is the advanced process of the multiplication. Till last year you learn it with the easy method, right? Easy method. I mean the simple method. Binomial, how to binomial product with the binomial. Now this is the different. 8a plus 3b whole square. Now in this, okay, now in this questions, now I am taking, I think, subtraction. No? Here in this second example, subtraction sign is here. What is your subtraction identity? A minus b whole square is a square minus 2ab plus b square, right? According to this identity, what is a here? Here,
A is 2.
yeah, a is 2x and b is 3y, right? Now we'll substitute in the this formula. So a is 2x means 2x whole square minus 2 times 2x times 3y plus 3y whole square. Now simplify it. 2x square. Do you know how you will solve it? 2x square. Look at this side. 2x square means what? 2x times 2x, isn't it? Any confusion? Huh. Now 2 times 2 will be 4 and x times x will be x square. So how you will write it? 4x square. Any confusion?
No.
Any query? Yeah. Next, solve it this, because all three are in multiplied. So we will solve together. So 2 times 2 is 4. 4 times 3 is 12. 12xy. Got it?
Yeah.
Plus 3y whole square. Again come to this side. 3y whole square means 3y times 3y. So 3 numeric value, wait. Yeah. So numeric value multiply with the numeric value, which is 9. 3 times 3. And y you will multiply with a y, like a monomial multiply with a monomial. So it will become y square. So it is 9y square. Now you got the answer. 2x minus 3y whole square is 4x square minus 12xy plus 9y square. Any confusion, any doubt, please let me know.
No.
I can clear right now. So it's a very simple, bacha. Whatever given the values here, okay? So you will consider first term as a, second term as a b, and substitute in your identities properly. And then remember the last grade algebraic expressions multiplication, how we have done it. So we have done like 2x square. So 2x multiplied by 2x, it will giving 4x square. Same 3y square, you will multiply 2 times, so you will get 9y square. And this middle term is same like 2 times 2 is 4, 4 times 3. So first always remember, first you will multiply all the numeric values, then variables. Okay, don't confuse it, don't mix it, and never write it variable first. Okay, I have seen many students write it in this way, like the 4x square, they can write it in the x square 4. No, this is the wrong variation. Okay, always numeric value first, variable second.
It also don't look right.
Yes, so always it's a format of the algebra, you can't be changed. So first always prefer the numeric value, then the variable. Numeric value, variable. Numeric value, variable. Always the sequence. Now this is the third question based on third identity. So first see 2x plus 3y, which is with the plus sign, 2x and 3y with the negative sign. Always remember these terms should be the same. Okay, these two always be same and these two always be same. Then you can only use the identity. Got it? So what is this identity? So a plus b.
So you need to combine the both 2x and 2x?
No.
I guess.
No. 2x plus 3y, 2x minus 3y, right? So now your identity is third identity, a plus b, a minus b is become a square minus b square. This is the easiest identity. How? See, what is a here? Can you tell me? A is 2x, right? B is 3y.
3y.
Just substitute in your identities. 2x square
2x.
minus 3y square, right? So what will be the solution? 2x square, as I discussed, 4x square and 9y square. That's it, done. No need to multiply with the distributive property. Will not use the distributive property. Okay? Understood the third property?
Yeah. Yes.
Yeah?
Yes.
No confusion?
Yeah.
So this is the last example with the last identity.